So up to this point, we spent a lot of time talking about the different phases in a stream. We talked about how you make a stream. We talked about how you can use the factory methods like stream and parallel stream. We'll talk about parallel stream a bit more later. We talked about how you could use splitterators in order to be able to take a stream and split it up into chunks. We've talked about how you could have intermediate operations, which are things like map, map to int, filter, drop while, take while, flat map, and so on. We talked about a whole spate of terminal operations, which are things like collect and for each and reduce, and then a few other variants of all those kinds of things like find any and so on. And then we also talked about some of the more kind of advanced usage of these features. In particular, we talked about sort of how things are implemented under the hood, as far as how streams are created. And we also talked about how you can implement non-concurrent collectors. And so we'll talk more about concurrent collectors later. Now that we've kind of got all the different pieces out of the way, I want to give an extended case study walkthrough for something called the SearchStreamGang program. And we're going to start, since we've been talking about sequential streams, we're going to talk about the sequential SearchStreamGang example first. And this is a really cool program, and it's actually a framework for a whole family of programs, as we'll talk about later. And these programs all do the same thing, but they do it in very different ways as far as how they're implemented, what features of Java they use, what concurrency models they use, what parallelism models they use, what frameworks they use, and so on and so forth. So it'll give us a chance to kind of compare and contrast all these different techniques, and you'll be able to do apples-to-apples comparisons of how it all works. This example is also more interesting than the simple search stream program. So it's similar in some ways, but it does more stuff, and it's cooler. So let's first start by talking about this. This is a revision of yet another program I wrote called the SearchTaskGang. We won't really talk about that in this course. The SearchTaskGang program showcases the use of something called the Java Executor Framework for tasks that are embarrassingly parallel. Hopefully you know what that means by now. It means that all the tasks can run independently without having to worry about depending on each other, so they can run at the same time. And this illustrates various Java executor framework mechanisms like the executor, executor service, and executor completion service. We won't really talk anything more about that family of classes in this course, but it'll be covered in the spring. So if you're curious, you can come back and take that. SearchStreamGang, as I mentioned before, is a more powerful version of simple search stream. Some things are the same. There's a lot of the same concepts of mapping and filtering and collecting and so on, but what we're working on here is much more interesting input. Before we had, the lyrics to the do-re-mi song, and the search words were the do-re-mi song words. SearchStreamGang, as you'll see, has got much more interesting search phrases and lots cooler way of outputting the data. In particular, what SearchStreamGang does is it uses very complex regular expressions to find phrases, not just words, but phrases in the complete work of William Shakespeare. And I've kind of given you an overview of the body of William Shakespeare work before. But basically, what you can do here is you can have the works of Shakespeare, and then you can look for phrases like brevity is the soul of wit. And it'll tell you where that appears, what play and what index into the play that particular search phrase appears. And a phrase can match anywhere within a line. And in fact, because we use really cool regular expressions, the phrases can actually match across multiple lines. So we could give this as a search phrase. What's in a name? That which we call a rose by any other name would smell as sweet. And it'll actually go ahead and find those matches across line breaks. And I'll show you the regular expression later that does that. It's very, very complicated, but very cool. What makes this particular program particularly interesting is the fact that it defines a framework for a whole pile of Java concurrency and parallelism strategies. So it illustrates sequential streams, which is what we're going to talk about here, but it also talks about parallel streams. It uses a more advanced form of parallel streams involving something called parallel splitterators, and then it also uses completable futures, as well as a bunch of other stuff. So if you're programming, for example, with RxJava, it has some RxJava examples too. And what we can do with all these different implementations, as you can see here, is we can come along and do apples-to-apples comparisons to see which approaches perform best. And this is just a little snippet of this, but this is showing how if you were to run this program and do a bake-off between the different approaches, the sequential versions obviously take a long time to run because they're only using one core, whereas the parallel versions run a lot faster. And that's pretty cool. One of the other things you'll see is that you can go from the sequential version, which is down here, to the parallel version, which is up here. And this parallel version is much faster than the sequential version, and it's just about no change to the code at all. It just changes stream to parallel stream. Now, if you want to go even faster, you have to do more sophisticated things like use parallel splitterators. But we'll talk about that in probably maybe Wednesday or maybe early next week. We'll start talking about that. So this is a very useful kind of bake-off-like approach. And we're going to focus on those concurrency and parallelism strategies after we first cover sequential streams. So the particular class we're going to look at that showcases sequential streams is called Search with Sequential Streams. Not a very profound name, but it tells you quickly what it does. And we're going to focus on two of the methods in that class, one called process stream and one called process input. And you'll see that process stream is kind of the overall stream, it creates a stream that kind of drives the overall processing of the works of Shakespeare, searching for these phrases. And then we'll see that phrases to find is what's called every step along the way to find a given phrase in a given work of Shakespeare, or actually a set of phrases in a work of Shakespeare. And this will illustrate various aggregate operations we've talked about before, and we'll give a little different slant on how they work. So we'll use map, filter, collect, and so on in this example. Okay, so that's basically kind of the high-level view. Let's talk briefly about what process stream does. So it's one of the methods. What it does is it uses a sequential stream, so that means it's running in the main thread of control, and it's going to search a list of input strings in a single thread, and then it's going to call out to the process input method to find the phrases in that string. And of course, each input string corresponds to a work of Shakespeare. So Hamlet, Macbeth, Julius Caesar, Twelfth Night, whatever your favorite Shakespeare works are. So that's process stream. And what you get back is a list of lists of search results. And we'll talk later about why we have a list of lists and how we're going to flatten those things using flat map in a later method called print phrases. There's also another method called process input. And this is a subroutine, essentially, that's called by process stream. So as you can see, process stream will call process input. And what process input does is it also uses a sequential stream. So it's using the same thread of control as the other method, and that's kind of calling it. And it's going to use that one thread of control to search a given input string, like Hamlet or Macbeth, to locate all the occurrences of the phrases that we're looking for. So we've got a bunch of phrases that we're interested in, and for a given work of Shakespeare, it'll go and look to see whether the phrases match. It returns a list of search results, and it will only contain entries in that list that are not empty. Okay, so that's just a quick overview just to kind of give you the big picture and visualize the different elements that we're going to talk about here.